Hello, now we're at 1.05 Measuring Lengths Part 2. Let's just start off with our need to knows. When you get finished with the video, please read the lesson in the LMS, completing your student guide at the same time. Then work on the assigned problems in the problem set. Be sure to read through the pages in the reference guide to help you get more understanding, and be sure to attend CC, and if you need to, attend tutoring in TOGA. And be sure to ask questions before you take the quiz because there are no retakes or corrections on the quizzes. When you do have questions, please go and post them in the Raise Your Hand section of Unit 1, and please IM me if you need a more prompt answer, and K-mail me with your course name and section number and exactly what problem you got questions with. And last but not least, you can call me. On to the lesson, Measuring Length Part 2, and we're still working on the same big idea that measurement is the process of using a unit to determine how much of something you have. Our objectives in this lesson is to determine if line segments are congruent, identify and use the segment addition postulate and the segment congruence postulate, and identify a point that is between two other points. Some new terms we're going to cover are the word between, and that is the position of a point that has collinear points. That means all points are on the same line. See, the position of a point that has collinear points on either side. If point B is between A and C, then the length of segment AB must be the length of segment BC equals the length of segment AC. I read something wrong there, but y'all read through it. Congruent line segments, those are line segments that have the equal length. The length of a line segment is the distance between the segment's endpoints. Okay, the first postulate we're going to look at is the segment addition postulate. This kind of reads like that between definition. If B is between A and C, then AB plus BC equals AC. There's the word between, okay? Also, if AB plus BC equals AC and ABC are collinear, they're all on the same line, then B is between A and C. The next postulate is the congruence postulate. If two segments have the same length as measured by a fair ruler, then the segments are congruent, and this is the symbol we will use for congruent. Also, if two segments are congruent, then they have the same length as measured by a fair ruler. Now what I want us to do is look at segment EF and segment NM on the number line. First, we have from E to F. Okay, so the distance from E to F is 5 minus 1 equals 4. Okay, so it's 4 units from E to F. Now we're going to look at segment N to M. Notice that N is 4, M is 8, and they just wrote it down here, 8 minus 4 equals 4. Okay, so EF is 4 units long, NM is 4 units long. Now then, this tells us that the measure of EF equals the measure of NM. It also tells us that segment EF is congruent to segment NM. So here's an important rule to remember. Measures are always equal, figures are congruent. So 4 equals 4, but segment EF is congruent to segment NM. Okay? You don't ever say 4 is congruent to 4. You always say 4 is equal to 4. And when you're talking about the actual figures, they're always going to be congruent, not equal. Okay, now let's talk a little bit about congruent line segments. Of course, we know they have equal length, But what's important is that they don't have to lie on the same line. So if you look here, here's segment AB and segment BC. These little tick marks right here tell me that segment AB is congruent to segment BC, just as they've written it right here. Notice how GH is going vertical and EF is going horizontal here, but they both have two little red tick marks on them. Okay, those little tick marks there are telling me that segment EF is congruent to segment GH. So just so you know, they don't have to be on the same line like in this picture. Okay, let's look at some examples. It says, do not assume that the side lengths and angles are drawn to scale. Only information that is explicitly given or marked can be assumed. So don't ever make any assumptions about anything in geometry. Okay, it says point H is on segment QP, and we can see that too. It says HP equals 15, so this right here is 15 units long. Oops, sometimes this thing just doesn't like for me to make straight lines. QH, this section right here, is 44 units long. And see, this is why you can't assume anything, because just by looking at this picture you would think that QH and HP were the same size, but they're not. Okay, it says if HP is 15 and QH is 44, find out what the value of QP is. So this is how I write these things out. A lot of students will skip this step, but I like it because it helps you identify where you need to plug what in. Okay, so see how I wrote out? Well, I know if I take HP plus QH, I can calculate what QP is going to be. So HP is 15, QH is 44. So I can do some quick math here. I can say 44 plus 10 is 54. 54 plus 5 is going to give me 59. I'd always suggest using a calculator if you've got one. So QP equals 59. Okay, we've got the same picture. Point H is on QP. We've already done A. We don't have to worry about that one. So if QH here is 91 and QP, I'm going to write it out here, is 116, then find HP. Alright, so I'm going to do the same thing. I know that I can take QH plus HP will give me QP. QH, oops, is 91. I don't know what HP is, and I know QP is 116. So I bet some of you could have done this in your head. See, I gotta remember all my stuff from algebra. Okay, so 6 minus 1 is going to give me 5. 11 minus 9 is going to give me 2. Well, that just looks horrible. So my answer is going to be HP equals 25. Let's look at what this one says. HP equals 310. QP equals 361. They want to know what QH is. So I'm going to have to do the same story all again. QH plus HP equals QP. This is the segment addition postulate, by the way. QH, I don't know what QH is, plus HP is 310. QP is 361. So I'm going to subtract 310 from both sides. So 1 minus 0 is 1, 6 minus 1 is 5. So QH is 51. There's my answer right there. Okay, it says for each set of points determine the following. Whether the points are collinear, which point is between the other two, and if the points are not collinear, write none. So I have R, S, and T are my points, and I just looked at what was written here. Wow. Let's look. R, S, T. Oops. There's me a line segment. Okay. So they're saying that this right here would be 13. From S to T would be 21, and then from R to T would be 8. So that's not working. So let's look. Okay, we've got the biggest number is 21. Okay, so this would be S and T and R. Does everybody see where I got that? Because your biggest number is going to be the length of the line segment. Okay, and then 13 and 8 is 21, so I could say from R to S is 13, and from R to T is 8, and so A, yes, and I'm going to write out here collinear. I had to remember how to spell it right quick. And B is which point is between the other two. R between S and T. Now realize I was still using the segment addition postulate. I was going, okay, I knew the whole segment had to be 21 based on this, and that's how I knew the endpoints were S and T. Well, if S and T were the endpoints, R had to be the point in the middle. Okay, so then I just figured out, okay, SR is 13, RT is 8, add those together, they're 21. Yay, there's my answer. For each set of points, determine whether it's collinear. Okay, so let's look. Based on what I learned last time in my last problem, and you notice this always looks like the middle point's exactly in the middle. Okay, 52 is the biggest number. Okay, right there. So that means X and Z have to be the endpoints. Y is going to be in the middle. This right here tells me X to Y is 14. Oops. And Y to Z is 7. Okay, 14 plus 7 equals, I believe, 21, which does not equal 52. Okay, so non-collinear, and since they're non-collinear, that means B is going to be none. There you go. Oh, I have a lot of examples in this one. This video is going a little longer than I wanted to. If RT is 60, Then find the indicated values. So they're saying this whole segment is 60. Okay, this is what you do. You've got your segment addition postulate, okay? RS plus ST is going to equal RT. R to S is 4x. S to T is 3x plus 11. And all of that has to equal RT, which is 60. Now your algebra just kicks in. 3x and 4x is 7x. I subtract 11 from both sides. So I'm going to have 7x equals, oh, that's an 11. Whew. My writing is atrocious with this. So 16 minus 11 is going to give me 49. And I just did that quick in my head. I said 60 minus 10 is 50, minus 1 is 49. So I'm going to just rewrite this over here. 7x equals 49. Y'all know you got to divide both sides by 7 to get that x all by itself. So x is going to equal 7. They want to know what RS is. So 4 times 7 is going to give you 28. And then 3, this thing doesn't like me to make 3's, times 7 plus 11, that gives me 21 plus 11. So 21 plus 10 would give me 31, and I add an extra one to it, that'll give me 32. And if you do the math right quick, 32 plus 28 is going to give you 60. And that's how you check yourself. Dun dun dun, we're finished. There's some helpful links for you that you'll find in Doc Sharing. We've learned today that line segments have the same measure, that have the same measure in the same units are congruent. If point B is between points A and C on a number line, then AB plus BC equals AC. And remember this, distance and measurements are always positive. You need to get the lesson done in the LMS. Be sure, if you haven't already, to read pages 7 through 9. Complete these problems in the problem sets. Be sure to contact me before you take the quiz if you have any questions. And any general questions you may have, you can ask them during CC on Thursday. Thank you. We'll talk to you later.